Now we will see the solutions. For the first question, a silicon sample A is doped with 10 raised to the power 18 atoms per centimeter cube of boron. Another sample B with identical dimensions is doped with 10 raised to the power 18 atoms per centimeter cube of phosphorus. The ratio of electron to hole mobility is 3. Then the ratio of conductivity of sample A to B is asked. You know that the conductivity is equal to mobility into carrier concentration multiplied by charge. So, for free electron conductivity, we have similarly for hole conductivity, we have here N and P are the dopant concentrations, and also the sample A is being doped with boron, meaning that it will be an p-type extrinsic semiconductor. Similarly, sample B will be n-type semiconductor as phosphorus are pentavalent impurity. So, the ratio of conductivity of sample A to sample B will be equal to the concentration of free electron and hole are provided to be equal. Therefore, we can cancel. The charge on the charge carriers is also same. The ratio of electron to hole mobility, which is Un divided by Up, is given to be equal to 3. Therefore, the conductivity of sample A to conductivity of sample B will be equal to 1 upon 3. Now for the second question, assume electronic charge Q to be equal to 1.6 into 10 to the power minus 19 coulomb and thermal voltage is provided to be equal to 25 millivolt. Electron mobility is provided 1000 centimeter square per volt second and the concentration gradient is provided to be equal to 10 to the power 21 per centimeter raised to the power 4. Now we are asked to find electron diffusion current density, and we know the formula is Q into diffusion constant of free electron multiplied by concentration gradient of electrons, and by Einstein relation we have free electron diffusion constant to be equal to mobility of free electron multiplied by thermal voltage. Therefore, the diffusion constant of free electron comes out to be 25 centimeter square per second. Now for finding the electron diffusion current, we simply have to put the values of different constant. The electron diffusion current density comes out to be equal to 4000 ampere per centimeter square. For the third question, a heavily doped n-type semiconductor has mobility of hole divided by mobility of electron to be equal to 0.4. Doping concentration to be equal to 4.2 into 10 to the power 8 per meter cube. Intrinsic carrier concentration is provided 1.5 into 10 to the power 4 per meter cube. Now we know that the conductivity for intrinsic semiconductor is equal to intrinsic carrier concentration multiplied by magnitude of charge on an elementary charge carrier multiplied by mobility of hole plus mobility of free electron. For n-type semiconductor, conductivity is equal to and also we can assume the free electron concentration to be approximately equal to doping concentration. Also, you can see that doping concentration is significantly greater than intrinsic carrier concentration. Therefore, N naught will be significantly greater than P naught. So, we can neglect this term. We will get the conductivity of free electron to be equal to charge multiplied by mobility of free electron multiplied by free electron concentration. We are supposed to find the ratio of conductance of n-type semiconductor to the conductance of intrinsic semiconductor. Remember that conductance and conductivity are different, like the way resistance and resistivity are different. But here, since we are supposed to find the ratio of conductance for the semiconductor with same dimensions, and also length and area is not provided. Therefore, we can simply find the ratio of conductance by finding the ratio of conductivity. Now, by dividing the numerator and denominator with free electron mobility, we will get also N naught is equal to Nd. Putting the value of different parameters, we will find the final ratio to be equal to 2 into 10 raised to the power 4. These two questions are actually very simple. You are supposed to find the values at x is equal to 0.5 micrometer, but this is provided just to confuse you, because at every value greater than 0 and smaller than 1, the electric field and electron drift current density will be same. The situation changes at x is equal to 0 and x is equal to 1 micrometer, but otherwise the values of electric field and electron drift current density will remain same at all the other values. Now, for the fourth question, the magnitude of the electric field at x is equal to 0.5 micrometer is, you know that electric field intensity is equal to negative of potential difference between 2 points divided by distance between the 2 points. Since we are supposed to find only the magnitude, we can ignore the negative sign. Therefore, the magnitude of electric field will come out to be equal to 1 volt divided by 1 micrometer, which is equal to 10 to the power 6 volt per meter. But the options are provided in kilovolt per centimeter, so we have to change its unit from volt per meter to volt per centimeter. And after changing its unit, the magnitude of electric field will come out to be equal to 10 kilovolt per centimeter. So C option is correct. Now the fifth question asks the magnitude of the electron drift current density at x is equal to 0.5 micrometer is. We know that electron drift current density is equal to free electron concentration multiplied by magnitude of charge multiplied by mobility of free electron multiplied by electric field. Also, doping concentration is provided to be equal to 10 to the power 16 per centimeter cube. You should know that at 300 Kelvin, intrinsic carrier concentration of silicon is approximately equal to 1.5 into 10 raised to the power 10 per centimeter cube. And for completely ionized extrinsic semiconductor, we have free electron concentration to be equal to but you can see that Nd is significantly greater than Ni. Therefore, we can neglect this term. And after solving the expression, you will find the value of free electron concentration to be approximately equal to doping concentration. This approximate sign comes only because we have ignored intrinsic carrier concentration. Now, electron drift current density comes out to be Nd into Q into mobility of free electron multiplied by electric field. Now we have to simply put the value of different parameters. Electric field we just found in the last part, which is equal to 10 kilovolt per centimeter. After solving, you will find the value of electron drift current density to be equal to 2.16 into 10 raised to the power 4 ampere per centimeter square. So A option is correct.